Professor Sehanat Prasaksuk, PhD. And the second session is plenary session 2 with Professor Michael Hall, and then we'll have a 15 minutes coffee break. The third agenda is the first panel session with our two invited speakers from State University of Malang and Lower Malang University. And after that, we continue to the second panel session with our two invited speakers from Jember University and Sultan Agung Tirtayasa University. After the panel session, we will have a lunch break and continue our conference at 13:15 p.m. The sixth agenda is parallel session for oral presentation 2, and last is closing ceremony, which will also include the announcement for the best poster and presenter.
The Honorable all the audiences, we are going to start our first agenda with our keynote speaker, Professor Sehanat Prasongsuk PhD from Chulalongkorn University, Thailand, and will be moderated by Retno Wulandari PhD.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, Om Swastiastu, Namo Buddhaya. Good morning and welcome back to our second days of plenary session in our seminar. To our distinguished chairman and all participants and honorable keynote speakers and also invited speakers. Today we will have an opportunity to have with us here Associate Professor Dr. Sehanat Prasongsuk from Chulalongkorn University, or I used to call Achan Sihanat in Thailand. And it is also a great honor and opportunity for me to welcome him again in Samarinda. Before we start, I would like to read the brief CVs, curriculum vitae of Dr. Sihanat. Is Associate Professor Dr. Sihanat Prasongsuk, is a lecturer at Chulalongkorn University, Bangkok, Thailand, and currently serves as the head of Botany Department at Faculty of Science, Chula. He was graduated and finished his doctoral degree at Chulalongkorn University, and at present, he produced more than 50 research articles and becoming a reviewer at many peer-reviewed journals. He also member at many, more than one international science society. Also, he engaged a lot of joint collaboration with the university in Indonesia, and one of that university is Mula Warman University. Some of his research interests is fungal and plant biotechnology and plant biomass utilization and conversion. And to shorten the time, the title for his presentation today is Tropical Fungi from Biomass Degradation and Their Application in Biotechnology. So for Achan Sihanat, time and place is yours, and the audience, please welcome Dr. Sihanat. Thank you.
Mass Utilization Research Unit. This research unit was founded and established in 2004 by Professor Hansa Punnapayak, and we emphasize on the prospect of plant biomass and its application, and also the significance of association between plant and fungi and fungal enzyme, and also the product. So let me introduce you about the plant biomass. Plant biomass composed mainly of the cellulose, about 28 to 35%, and hemicellulose is the second one, okay, and the lignin is the latest one. So as if you can see from the slide, cellulose and hemicellulose are the polysaccharide, while the lignin is a polyphenolic compound. And another part of the plant biomass is the extractive. So we have a lot of students working on the extractive, the natural product from the plant, like Francisca, my former student, and also Devi Kusuma, my current student from Erlangga. So our strategy, starting from the biomass, and then we use a pretreatment to separate cellulose, hemicellulose, and lignin. And also today I'm gonna emphasize on the fungi that's used for the biomass degradation, like the fungi that produce cellulase. Cellulase can degrade cellulose in order to obtain the glucose for fermentation. And also, but today I'm not gonna talk much about the cellulase, but actually we have another work on the fabric modification by the enzyme called cutinase as well. But today I will mainly focus on another part that we have recently published a lot of work, like hydrolysis of the hemicellulose or silane. Silane can be degraded by the enzyme called silanase in order to obtain the xylose. And xylose also can use for fermentation and also the production of many kinds of products. And another part is white rot fungi. The enzyme called ligninase or ligninolytic enzyme produced from these fungi. And one of my students that work on this is Leno Urandari, working on the white rot fungi that produce a ligninase and then used for bioremediation, decolization, biopulping, and also biobleaching. As you know that fungi are the main degrader of the plant biomass in nature, and as such has an essential role in degradation and also the global carbon cycle. And also as you can see in the picture, that the lignocellulose can be degraded by the enzymes. Like the first one is the lignin degradation occur by the white rot fungi, and then the fungi can degrade hemicellulose and also cellulose into the monomeric sugar like glucose and xylose, and then this one can use for fermentation. And we're gonna emphasize on this kind of the fungi that are responsible for the biomass degradation. And the application, definitely in biotechnology, there are many applications, like in the industrial sector, like in food and feed technology, pulp and paper industry, detergent, textiles, and also the biofuel and biochemical production. So let's start with the first fungi that degrades cellulose. It's an old work of the Professor Hansa working on the fungi. He isolated one of the fungus, Acrophylophora species, from the agave plantation in Thailand, and then he found that the fungus produces an enzyme at about 45 degrees Celsius, and then the cellulase can be used for the ethanol fermentation by using the simultaneous saccharification and fermentation of agave fiber. So today I'm gonna focus mostly on the hemicellulolytic enzyme. The hemicellulolytic fungus that I work in this group is the Oreobasidium. Actually, Oreobasidium is very important fungus. They have so many applications in biotechnology. But first is about the enzyme that's used for hemicellulose degradation or silane degradation. Actually, arabinoxylan is a major component of hemicellulose, and the enzymes, there are two enzymes that's responsible for the degradation. One is the endo-1,4-beta-silanase, used to degrade the silan into the sialo-oligosaccharide. And then the the sialo-oligosaccharide will be degraded by another enzyme called the beta-silosidase. The difference between these two enzymes is silanase is an extracellular enzyme. Beta-silosidase is the intracellular enzyme. And then the product is xylose. So why we interested to study about Oreo-basidium? Because this yeast produce a cellulase-free silanase, which is good for the like a biopulping or biobleaching. And also the enzyme active at high temperature that so far only reported from the tropical strain of Oreo-basidium. So we isolate a lot of tropical strain of Oreo-basidium. And also the enzyme can be produced when cultured in the agricultural waste as a substrate, so we can reduce the cost of the enzyme production. So from the phylogenetic tree, we can find some of the high silanase producers. So we select some for the study later. So let me introduce about Oreo-basidium a little bit. This one is a yeast-like fungus. It means that they have yeast and also the mycelium phase in the life cycle. And sometimes they call it black yeast due to the melanin pigment production. If you can see from the picture here, in the younger stage, the colony is very smooth and creamy. But later, in the late culture, the melanin produced, so we call it black yeast. For the taxonomic classification, this yeast have its own family. We call it Oreo-basidiaceae, but it's still in the Ascomyces. So we have if you would like to know about this yeast, I wrote the review published in Folia Microbiologica. So there's more detail about this yeast. And so we work on Oreo-basidium because it's produced so many beneficial products like a biopolymer, pullulan, beta-glucan. The enzyme, today I'm going to emphasize on the hemicellulosic enzyme because it's used for biomass degradation. And for the food and feed, the yeast itself can use as a food or feed for the animal, we have the product also. And also it can use as a single cell protein for the human in terms of we have the scaring of the scarce of the food. And also the antifungal agent like Oreo-basidium. So we are the first group that isolate Oreo-basidium in Thailand. And we found that we have some of the tropical characteristics of Oreo-basidium. We isolated it from the phyllosphere, many crop plants, various tropical fruits, and painted and wood surfaces, and also ceiling and bathroom wall. So at that time, the report so far only from the temperate zone country in US or in Germany. But we are the first group that isolate the tropical strain of Oreo-basidium in Thailand. So we use the enzyme. This one is produce a hemicellulase or the silanase, and then we use an enzyme for the pulp bleaching. This one we use the rice straw pulp. And then if you can see that the enzyme, when we characterize, the enzyme has the optimum condition at 70 degrees Celsius. This is the character of the tropical strain of the fungus. And at 70 degrees Celsius, even it has optimal condition, but the stability of enzyme is not that good. So we use some of the sugar alcohol like sorbitol to stabilize the enzyme stability. So when we found that sorbitol is very good for the enzyme stability. So we use that condition for the pulp bleaching, and we found that we can increase the brightness of the pulp by using the enzyme and also with sorbitol higher than the hydrogen peroxide alone. And also, surprisingly, we found that the tear index improved compared to the untreated pulp and also the hydrogen peroxide treated alone. So we optimized the enzyme production, and we found that the enzyme can grow with corn crop ammonium sulfate and also potassium dihydrogen phosphate and also twin 80. And also we optimized the concentration for the enzyme production, and we use response surface methodology. We collaborate with Professor Sung-Wook Kim at Korea University, and we got about four-fold higher than the original enzyme activity. So we use this enzyme not only for the pulp bleaching, but also for the silo-oligosaccharide production. In Thailand, we have a lot of biomass like coconut grass, vetiver grass, napier grass, and also the water hyacinth actually is introduced from Indonesia by King Chulalongkorn to Thailand. And we have a lot of problem with the water hyacinth. So we try to utilize this kind of the weed and also the weed biomass for the biochemical production. This time we extract the silane from the biomass and then use it for the silo-oligosaccharide production. And this silo-oligosaccharide has a very good activity, especially for the prebiotic activity by stimulating the growth of probiotic bacteria. So let's move to another enzyme, the beta-silosidase. As I told you before, that this enzyme is intracellular enzyme, not extracellular enzyme. So when we produce this enzyme, we need to extract the enzyme from the yeast cell. So we use the lyophilization and then extract the enzyme from the yeast cell. And then we characterize the enzyme, and we found that our enzyme is quite distinct from the other reported beta-silosidase. So we published this as the new property of the enzyme, like from our strain, the CBS strain. And then we have a collaboration with Rinji Akada, Professor Akada at Yamaguchi University for the collaboration for the enzyme characterization. Next is about the use of beta-silosidase. Only the silane degradation by using the silanase is not enough, so we incorporate the beta-silosidase to improve the bioconversion of the silane. So when we put the beta-silosidase into the silane degradation, we optimize using the response surface methodology again, and then we got about 80% of the conversion of the silane into xylose. Then we use the beta-silosidase. This is another application for the production of we call it alkyl beta-D-silosides. We use the silane from back liquor and then use another activity of beta-silosidase. Not only beta-silosidase, we found that not only the degradation of the silo-oligosaccharide into xylose, but this enzyme can do the trans-silosylation activity. So we got the two new compounds like a pentyl beta-D siloside and also hexyl beta-D siloside. So we try to characterize these two compounds, and then we found that these two compounds can use as a wetting agent. We have help from Dr. Rico Ramadan also for the structural characterization of these two compounds. And another enzyme that we just published recently in Theory Biotech, this is a work from our master degree student in our lab, Saria from Erlangga University in Indonesia. And the new enzyme from the Oreobasidium is a beta-manganase. This manganase used to degrade the galactomannane. And where we found the galactomannane is come from the spent coffee ground. And then we extract the galactomannane, and then we use the enzyme, the beta-manganase that produced from Oreobasidium to produce the mono-oligosaccharide. We optimize the condition of the degradation by the response surface methodology. And then we found that our mono-oligosaccharide can use for the prebiotic property as well. Uh, Next. Okay, next is another product from Aureobacillium. I already mentioned about the enzyme, the silanase, silosidase, and manganese. And this one, this yeast produce very valuable product. We call it pullulan. Pullulan is biopolymer or the polysaccharide. Actually, you can eat this one. This is a maltodextrose unit of the polymer of the pullulan. And pullulan can use for the, this one is made by Pfizer company, and the Pfizer company sell this as a Listerine cumin pocket pack. And if you go to US, you can find this one. You can find this one a lot. And also, this pullulan can use for the food coating. And now the new application is for capsule of the medicine. And in our lab, we also can produce the pullulan and then make it as a pullulan film used for the application as well. So go back to the work that I start from the 2003, I think. This work is from one of the students in our lab, Dr. Montarop. Actually, at that time, she able to isolate 3 Aureobacillium pullulan, SUPR, and CU from the collection of the different habitat in Thailand. And we found the first 3 pullulan producers. Okay, and then we got the optimal condition for the pullulan production. And later, I have a collaboration with my professors in Rutgers University, Professor Douglas Everley. He passed away 2 years ago. And then at Rutgers University, actually he's very famous for the cellulase production because he's the one who created the mutant strain of Trichoderma raceyi, RACI30. And this one is still used for the commercial enzyme cellulase production. And we can get more of the isolate of Aureobacillium, and also we found some of the characteristic of the tropical fungi, like the Calivarian strain, and we did the molecular identification using the internal transcript spacers, and also we produced the pullulan, and then we confirmed the use of IR and NMR for the structural characterization. Then we published these 2 papers in World Journal of Microbiology and Biotechnology, and also in the Journal Industrial Microbiology and Biotechnology. After that, we have a collaboration with the USDA group in Peoria, Illinois. We send a student to work over there, and then we can get the very, very new multi-locus phylogenetic analysis. We have about 46 more tropical strain of Aureobacillium, and then we divided this into 12 distinct clades of Aureobacillium, and some of them, like clade 12, we can find that these 2 strains in the clade 12 not produce pullulan but produce another kind of polymer. So not only this work on the phylogenetic analysis, we have more of the strain from the coastal area in Thailand, and also we found another species of Aureobacillium. It's called Aureobacillium melanogenum. This is the work of the Benjawan in our lab. And next one is about the enzyme. The pullulan produced in late culture has a problem with the molecular weight decrease. So we assume that the enzyme that produced from Aureobacillium that degrade pullulan is the alpha amylase. So we detect the alpha amylase, and then we found the gene of alpha amylase gene, and then we construct the phylogenetic analysis of the alpha amylase gene of Aureobacillium for the first time by collaboration with the group of USDA. And then Another biopolymer is called the obesidenolite beta-glucan. As I told you before, in K-12, they produce the, not pullulan, but they produce the beta-glucan. This beta-glucan is, the structure is quite different from the beta-glucan from yeast, like Saccharomyces, because the branching of the 1,4 and 1,6 in the molecule. And we optimize the beta-glucan production, and we got the yield about 10 gram per liter of the beta-glucan. And then we have another student working on the beta-glucan to improve the yield. Actually, this is the work of Nan Tachapon, one of my master degree students. And she got the supplementation of the sunflower oil in the medium. And then she got about 80 gram per liter of the beta-glucan. It's very high yield. So, and this beta-glucan also tastes for the artificial saliva and artificial gastric juice resistant, and we found that our beta-glucan very resist to these two systems, so it can be used for the prebiotic properties. So we incorporate the beta-glucan into the gummy jelly. You know, we have a collaboration with food technology department, and we also test the property, and then we publish this in the tier 1 publication, is in LWT, very high impact factor, about 6. So let's move to another one. It's another product from this yeast. This tropical yeast is very important because it's produced many kind of product. The oreobecidin. Oreobecidin is a cyclic decipeptide that have the antifungal activity. So it's quite weird that oreobecidin is a fungus and have the antifungal activity. So it might be used for the competition in nature. So they have the activity against some aspergillus, some candida, and also cryptococcus by the inhibition of the sphingolipid synthesis in the fungal cells. So we produce the first, we isolate oreobasidium from the bathroom surfaces. I think this one we have been to a lot of bathroom surfaces in Bangkok of Thailand. So we collect some of the 10 oreobasidium isolate, and we found that some of them produce the antifungal agent, and then we publish this in African Journal of Microbiology Research. And then we try to optimize the antifungal agent production. Okay, and when we taste first for the screening of the oreobasidium that we have in our lab, and we found that NRL58536 has a very good antifungal activities against some of the aspergillus. And then we try to supplement the production of the oreobasidium in the medium by using different amino acids. Because this antifungal agent is a cyclic decipeptide, so we incorporate the amino acid that we found in the structure of oreobasidium into the medium. And we found that the amino acid can stimulate the activity of the antifungal agent. So we publish this in Applied Microbiology and Biotechnology. Yeah, we confirm the structure of the oreobasidium that produced by the proton NMR and also multi-top MS. And the last one is about the fungi that produce the enzyme called ligninase. As you know that viral fungi are efficient microorganisms that able to completely degrade the lignin by the enzyme called ligninase or ligninolytic enzymes. There are three main enzymes: lactase, lignin peroxidase, and manganese peroxidase. Why this viral fungi is important? Because it's used a lot for bioremediation and also for biotechnology like biopulping and biobleaching. And in our lab, we work on these two main applications. One is for the detoxification, like a pH degradation, like one of the work that Retno has done for the pH degradation. And also the decolorization, like palmy wastewater decolorization, and also the synthetic dye decolorization. Why we interested in pH degradation? Because pH is a carcinogenic compound that occurs through the incomplete burning of organic compounds. As you can see here, the structure of the pH, 16 pH are very, very dangerous actually. It's because it's carcinogenic. So we start by collecting the fungus called Ganoderma lucidum. This one actually is very important for the health benefit, but we also found that this fungus produce a number of the enzymes like a lactase production. This one we collaborate with Professor Kurt Messner at Vienna University of Technology, and then we found that these lactase can degrade all the 16 of pH, but some can efficiently degrade without the mediator. Normally, the lactase work very well with the mediator, but this one, without the mediator, also can degrade pH. Okay, and also we have another master degree student, Pavina, is working on another fungus called the Pycnoporus coccineus, and this one also can degrade some of the pH as well. And with the collaboration with Imai Sensei at Yamaguchi University. And as you can see here, we test some of the pH, and it's very effective for the pH degradation. And then let's move to the decolorization. I think this work is, I went to Japan and then worked in my sensei lab at Yamaguchi University, and we found new fungus, the Didaliopsis, that is the thermotolerant viral fungus. It means that it can grow not well at the higher degree like 40 degrees Celsius, but it can tolerate. So we use this fungus for the decolorization of pulp mill wastewater. We have a problem with the color of pulp mill wastewater in the pulp mill industry in Thailand. So we apply this one for the decolorization. And surprisingly, we not only can decolorize the pulp mill wastewater, but this one can also reduce the COD, chemical oxygen demand of the wastewater as well. So another work is on the decolorization, but this one is for the reactive dye decolorization by our PhD student, Paulada Pernponsakul. She's the one who firstly isolated the resupinate viral fungi. Actually, this one is look like lichen, but it's not lichen, it's a mushroom, but it's not produce a fruiting body. So we found one of the very effective resupinate viral fungus, Phanerochitis sordida, and these sordida can completely decolorize reactive black 5 within 3 days. And then we find the condition for the decolorization, and also we test the metabolic degradation of the decolorization by HPLC, and then we test the metabolic degradation by the phytotoxicity test using 3 of the plants like a Phaeolus, sorghum, and also sea maize. And then we found that there is no toxicity against the plants, okay, from the degradation product. So it means that the degradation product can release into the environment safely. So that's about my talk, but we cannot be successful without the partnership from different countries, like also in Thailand, also in US, in Japan, in Germany, and also from Indonesia. Definitely, we have a lot of collaboration with Indonesian Institute, like the first with Mulawaman. Actually, I have friends here, a lot of friends here, and also my former student here. And actually, the collaboration with Mulawaman starting from Kyoto University when I visit Kyoto University and I met Professor Rudy, the Dean of the Faculty of Forestry here. And then we have a collaboration. So we expand the collaboration with Indonesian Institute like with Erlangga and ITS, Brawijaya and Unwaha. Okay, and this the PBURU member recently, actually, because we have some already graduate, like one of the here, sit here and there, and also one of my students just graduated. He's from Mulawan, Muhammad Taufik Hakiki. Actually, he's a very proud master degree student that graduated with Q1 publication in ACS Omega. And we have, recently we have 3 PhD students and also some of the master degree students, and still have 4 master degree students from Indonesia, 1 from Bogor and 1 from Erlangga, and the rest I can't remember. Okay, so there's a support from different agency of the grant, research grant that we get. And thank you very much for your attention.
Thank you very much, Achan Sihanat. And it's time for questions and answer. Is there any question from the floor? And if the Zoom participant would like to ask the question, please write a note in the chat column and I will read it out loud for the speakers. Yes? Oh, let me see the Zoom first. Okay. Floor? Yes, Professor Andrews.
Good morning, Prof. Sihanat. This is nice talk, yeah. Very nice regarding about the Panjai. Yeah. So as you know, Thailand and also Indonesia, this almost the same climate, like a tropical climate. Yeah. So some of your works about Pululan, so it's interesting because it can be used for cosmetic, right? So I want to know what kind of application in cosmetic. Is it for like make a masker or something? So yeah, it's very interesting. Yeah. Thank you.
Thank you. Actually, for the biopolymer, the Pululan that we work for many years, actually the application now expanding mostly into the cosmetic product. Yeah, I think it's very good, but because it's produced from the fungus, so I believe that it's no toxicity to human cells. And I think they have a paper on the toxicity. So it means that it can use for the application, for the cosmetic application. So actually it's interesting to use as a mask because it's also protect the moisture content for the cell. Yeah, very good.
Thank you very much.
Questions? Yes? Please briefly introduce your name and the institution.
Okay, so thank you for the opportunity. My name is Ersa. I'm from Department of Chemistry, Faculty of Mathematics and Natural Sciences, Mulawarpad University. So from all the fungus that are already you explained, is it possible that those fungi contain toxic compounds? And since you use the fungi to get enzymes, what will happen if the fungi accidentally meets the anti-fungi agents? Thank you.
What is the second question?
What will happen if the fungi accidentally meets the anti-fungi agents?
Accidentally
Reacted with the anti-fungi agents.
accidentally attack the anti-fungi agent.
Yeah. Yes.
For the toxic compound, we still, so far there's no report about the toxic compound from the fungi that we use for the in our lab. Okay, but for the second one is about the
What if the active compound become active, something like that, to the
fungus itself, right?
To the fungus itself.
So when we make a reaction between the fungi and it accidentally meet another anti-fungi agents, what will happen?
If two anti-fungi will meet, what will happen?
Yeah, we never try that one yet, but it's interesting what will happen. I really don't know, actually. Thank you.
Another questions from the left side or the right side? Yes, Budijan.
Thank you for the opportunity. I'm Dijan from Mathematics and Natural Sciences Biology Department. And I would like to ask about the wastewater decolorization by white root fungi. In your presentation that you mentioned about it's safe for the growth of the several plants, several species. And I just wonder what happens if we didn't do the decolorization. So it's by the decolorization, it will change the water contents. Thank you, Ajahn.
Okay. It's like we are in the seminar class, right? Actually, because I used to be her instructor in the seminar class. Okay, so it's a good question. Actually, if we don't do the decolorization, what will happen if we release like a RB5 that we use the dye or even the palmy wastewater, is gonna toxic to the environment because the dye normally is carcinogenic. Also, it's gonna happen to the plant or even the microbe surrounding that area. And also, if we release into the water stream, yeah, if the people use that one, it might affect to the human body in the accumulation effect. So in our scheme, we try to use the fungi to decolorize. Actually, because of the regulation of the industrial, I'm not sure in Indonesia, but in Thailand, there is no specific regulation for the color of the wastewater. They just say that it should be acceptable. So they don't know that they have the toxic compound. Even the pulp mill wastewater, if they use the chlorine will bind to the lignin. They call it chlorolignin. And this chlorolignin, very carcinogenic. So it's very important to treat or decolorize by degradation using our enzyme or our fungi. And then it's safe for the environment before releasing, okay, from the industry, something like that. I think it's very important to treat for the decolorization of the wastewater or dye wastewater.
The next question from the left or my left, is there any questions? Yes, Francisca.
Yeah, thank you for the
opportunity. So this is seminar class Achan. I would like to introduce myself. My name is Francisca Mariani. You can call me Ica. I am one of the student of Achan Sehanat. So from Chulalongkorn University. Okay, so for the question, actually I want to ask two questions, but the second already asked by Dijan. So just only the first, Achan. I saw that you present like the paper from 2018 about the, if I'm not wrong, like rice bleaching or pre-bleaching, something like that. And then there's many treatment. The last one is use silanase and sorbitol. And my question, actually, because this is the research already like 5 years to 4 years ago, but nowadays there's a news about the side effect of sorbitol. So then the question is, if we still use this treatment, how would happen later on to the rice? That is my question. Thank you, Achan.
That one is used for the pulp bleaching, right?
Rice bleaching, rice
straw.
Rice. Pulp bleaching.
The one that.
Oh, rice straw. Yes.
Yeah,
yes,
yeah,
sorry.
that's one, the rice straw. So it's not gonna be a problem.
Oh,
because
okay,
we
Achan.
use it for the bleaching.
Just only rice straw. Yes.
Yeah,
okay.
yeah, rice straw. So
Thank
it's not
you,
gonna be a
Achan.
problem.
Thank you very much for the last question. Actually, I have been informed from the committee that will be our last question. Thank you very much for Achan Sihanat for the very thoughtful and useful talk today. And please give Achan Sihanat a huge welcome, applause. And thank you very much for Achan Sihanat.
Ladies and gentlemen, in this session we will hand over a small souvenir to our keynote speaker. And the souvenir will be handed by Mr. Zeni Haryanto. Please come to the stage. This is an East Kalimantan necklace, Dayaknis. Dayaknis, yeah. And then this is a plaque. And this is the certificate. Okay, thank you. Ladies and gentlemen, the next keynote speaker is Professor Michael Cole, and this session will be moderated by Professor Enostanke Arong Eswood MP.
Good morning, ladies and gentlemen. Good morning. Okay, thank you very much. Yeah, I think here around 1,000 people attending this. I think maybe also in Zoom there is 200 or something. Okay, this morning we will have another session for the preliminarization. So Professor Michael Cole will talk with us about the sustainable management of large tropical forests in the Caribbean to ensure long-term productivity. I will read the CV from Professor Cole. It's a long CV, but I will shorten it. Professor Michael Cole have a long list CV, so I will just read it, the important one. So education training, he was graduated from University of Freiburg, 1986. It's long, yeah. And works experience, 2004 2013, he was head of Institute Federal Research Center Forest and Forest Product in German. And now he's a professor in University of Hamburg until now, from 2004 until now. And he has many projects, and mostly the project is in abroad country, like in New Zealand, and then there is in Fiji, and Brazil, Caribbean, Madagascar, and of course in Indonesia. He's doing peatland project in Indonesia. So the other, he has a project in Vietnam. Yeah, it's many kind project in abroad country. So of course he has many publication. You can search the publication by Googling it with the name of Michael Cole. So you can find the publication. So that's all the CV from Professor Michael Cole. You can find it later. So next, let's go to the talk of the Professor Michael Cole. So according to the committee, it will be by video. I ask, please, the committee,
Ladies and gentlemen,
you can
I would
start
like to
the
welcome
video
you very much
or
to
presentation,
my presentation.
by
Unfortunately,
Professor
there has
Cole.
been
Please.
some misunderstanding concerning the dates of the workshop and the dates of my traveling, and therefore I can't be with you in person, but you have to listen to my presentation as a video. However, I hope that you enjoy the presentation. I would like to talk about a project we were conducting for the UN Food and Agriculture Organization in the Caribbean. It's on sustainable management of locked tropical forests in the Caribbean. And we conducted this project to see how a locked over forest can actually be utilized a second time after the logging. And we developed some guidelines on how to adapt the forest management. The project had three objectives. First of all, we wanted to support the sustainable management of logged forests and put special emphasis on the productivity and the maintenance of the productivity and the prevention of further degradation. A second objective was to develop silvicultural recommendations for sustainable forest management. And the third objective was related to RED+. You know that RED+ uses sustainable forest management as one of the activities, and we wanted to see if silvicultural treatment of locked over forests is economically feasible and can be applied as a method for an activity. The project was carried out in 4 countries of the Caribbean: Belize, Guyana, Suriname, and Trinidad and Tobago. In the project, we looked at different silvicultural systems and logging times. The first was a polycyclic controlled selective logging, which was based on the minimum harvesting diameter and an allowable cut that was estimated from yield models. It was a private forest, it was privately managed, and the cutting cycle was 40 years. The next alternative was again polycyclic and selective logging, and it was conducted in a state forest. And this was a community that managed the forest with annual cutting permits, and the cutting cycle was 1 year. In the third alternative, again polycyclic controlled selective logging, which was again based on the minimum harvest diameter and the maximum allowable cut. And this was a large-scale concession with a cutting cycle of 30 years. And the last alternative was again conventional polycyclic selective logging based on the minimum harvesting diameter conducted in a state forest, and the cutting cycle was again 30 years. In each of the 4 silvicultural sites we assessed forest areas. You can see here the study site design that we applied, and we had 2 different layouts. In total, we assessed 10 sites, each of 100 hectares, so we have assessed a total of 1,000 hectares in these 4 silvicultural systems. When we look at layout 1, you can see that we have 4 groups of plots, 4 clusters of plots, each consisting of 10 by 4 individual plots. And if you add the size that we assessed in these 4 clusters, you get this 100 hectare in size. We had buffer zones between these different forest plots, so that we could actually avoid any interference between these plots. In one country we had to use a different layout, and that is mainly due to the fact that the logging areas were not large enough to apply this layout 1. But in total we had again 100 hectares for each of these study sites. Here you can see an overview on the 10 study sites that we assessed. We had these layout 1 in the private forest concessions, in the community forestry, and in the concession and the periodic blocks. And for one concession we had to use this layout 2 as the size of the logged over areas were not sufficient to place in these layout 1. What we did at first, in each of these blocks we assessed the total growing stock. And you can see here the species distribution within these different blocks that we assessed. For each tree that was assessed in a block, we assessed the tree species and then divided the species into non-commercial growing stock and commercial growing stock. The major finding we wanted to get was the abundance of the commercial. This slide shows the abundance of commercial and of non-commercial trees. You can see in red color the non-commercial trees, and you can see in blue color the commercial trees. And what you see right away is that there is quite a different abundance of commercial trees in these different sites that we assessed. When you look, for example, at the periodic blocks 1 and 2, you can see that we have here a very high abundance of commercial trees. When we look at the community forests, you see that we have a high abundance of non-commercial trees, and there are hardly any commercial trees left that could be utilized in future harvesting. So what you can see here is that logging the forests and the practices applied to log the forests resulted in a different abundance of commercial and non-commercial trees, which of course is very decisive for the future productivity. The next step was to look at the abundance of harvestable trees. The non-commercial growing stock is of course non-harvestable stock, and this goes into the residual non-commercial stock. When we look at the commercial growing stock, then part of this commercial growing stock can either go into the non-harvestable stock, that would be the residual commercial stock, and it can go into the harvestable stock, and that means it goes either to the residual commercial stock or the harvested stock. The decision on if a harvestable tree enters into the residual commercial stock or the harvested stock depends on the quality of the individual logs, which we will look at in a minute. This slide might look a little bit confusing, but let's go through it step by step. On each of the plots on the study sites, we assess the trees with a dBH larger than 25 centimeters, irrespectively if they were commercial or non-commercial species. From these trees, we identified the harvestable trees. That means those trees that reached the minimum harvestable diameter. And from these harvestable trees, then trees were selected for the actual harvesting. That left us with remaining commercial trees, which might not have reached the minimum harvestable diameter, or which are here harvestable trees which have not been harvested. From these trees, the remaining commercial tree species, future crop trees were selected, and then the number of future crop trees were identified that require some release treatments. And you can see now here these different categories of trees for the large-scale concessions, for the periodic block system, for the privately owned forest, and for the community-managed forest. Remember that these are different silvicultural systems that are lying behind these denominations. We look at the number of trees per hectare and on the average diameter, and we can see that we have a quite high number of trees with diameter larger than 25 centimeters in the large-scale concessions, in the periodic block system, and in the community-managed forests. The harvestable trees, they show a clear difference. We have a high number in the large-scale concessions and in the periodic block system, and rather low numbers in the privately owned forest and in the community-managed forest. Remember, in these community-managed forests, there was a harvesting performed every year. Then you can see that we have harvested trees, 8 trees to 4 trees, and we have a different number of remaining commercial trees. So this is actually the future of our forests then, and you can see that in these large-scale concessions we have a rather large number, 81 trees, and in the community-managed forests we have a low number, only 10 trees. From these we selected the future crop trees, and you can see that we have a rather high number of future crop trees selected in the periodic block system. And from these we identified the trees requiring release treatments, and you can see that there are 3 on average, with the exception of 1 tree in the community managed forests, and this is because there are only few trees left. Let's look again at some remarkable findings. First of all, you see here the harvestable trees. We have a maximum of 34 trees in the periodic block system and only 5 trees left in the community managed forest. And on the other hand, we have future crop trees that have been selected, 22 in the periodic block system and 6 in the community managed forests. But it is of course not only the number of trees that is decisive for sustainable forest management, but it's the distribution of the volume of the harvested trees. What you see here again for the 4 silvicultural treatments is the volume in cubic meter per hectare for the different diameter classes. And what you can see immediately is that in this large-scale concession, you have a very high number, a very high volume over especially the smaller and mid-sized diameter classes. And when you go, for example, to the community forest, you can see that there are almost no trees left in the larger diameter classes, and that you have a high volume in the low diameter classes, and then the volume is shrinking. You see in blue color the commercial residual stock, and in red color the harvested stock. So the red bars here, the red part of the bars is actually has been harvested, and the blue would be the residual stock that is left after harvesting. And you can see that in the community forest, by this logging, you even decrease the volume, the commercial volume in the different diameter classes more, and that there is even less left for future harvests. Remember that these four different silvicultural systems represent different management regimes. In the large-scale concession, and in the periodic block system, a minimum harvested diameter was assumed, and in the large-scale concession, there was a fixed minimum allowable cut. So there was the allowable cut, the volume to be extracted in each harvesting operation, which takes place every 30 years, was fixed. In the periodic block system, we had something similar, but here, in addition to the minimum harvestable diameter, we had individual tree sales, so the number of trees extracted was quite low in the past. And here again, we have a 30-year intervention cycle. When it comes to the private forests, we had minimum harvesting diameter, and the maximum allowable cut was estimated from a yield model. And obviously the yield model applied here was too positive in predicting the yield. So what was taken out based on the yield model was actually too much of the growing stock. And you can see that that led to a depletion of the volume in the higher diameter classes. And it's getting even worse when you look at the community forests. Here you have annual cutting in these forests. You have only the minimum harvestable diameter, which was actually reduced over time, and therefore more and more commercial trees were actually extracted from these forests, and that led to this almost degradation of the volume in the smaller diameter class. You find in literature on the sustainable management of tropical forests, of locked over tropical forests, the recommendation to apply the liberation of future crop trees. You can see this in this slide. You have in red the future crop trees that have been identified, so trees that have a high timber quality and are promising future harvestable trees. And these trees should be liberated from competitors, and you can see this in this lower slide. So there was actually these 3 trees and some smaller trees cut down so that these future crop trees got more growing space and could actually grow larger by this supportive measure. The cutting down of the competitors is of course associated with cost, and the question is, does it really pay off to cut down these trees? That means, is the growth of the remaining trees, of the future crop trees, promoted in a way that they actually grow that fast, that they compensate for the costs that were associated with felling? If you want to see if the future crop tree release is an economically viable, sustainable forest management measure, we have to consider 3 situations. The first is that we don't do anything. We have no future crop tree release. That means a tree is actually growing from time 1 to time 2. When we apply the future crop tree release, then when we look at the cost, we have as a cost of the future crop tree, which is associated with this tree. So when we look at the future, then this future crop tree must actually grow more than without a future crop tree. And the additional growth has to gain more money from timber sales than we invested in the liberation exercise. So what we see here is that we have here a future crop tree. We have the cost associated in time 2. This future crop tree actually grew larger, and by this we could actually gain some money from the future crop tree release. What you see here in gray color is the interest rate. So you have to see that the money you invest here is associated with an interest rate, so the cost actually is increasing in time 2. The cost to be considered is increasing in time 2, and so you have to take this difference between the additional growth and the cost of the liberation, including the interest rate. And so this would be the additional gain you would get from liberating this tree. But the situation can be different. Again, you have the tree, you have the associated cost, you have the associated cost plus the interest rate at time 2, but this tree is not growing that much as the former tree. And what you see here is that the difference between the additional growth and the cost associated with liberation and the associated interest rates is actually larger than this additional growth and the gain in money from timber sales. And here, this future crop tree release would actually result in a negative return, so the future crop tree would actually not pay. The same considerations hold when you look at the future crop tree release as an economically viable measure under REDD+. In REDD+, we want to produce more volume. That means we want to store more CO2, more carbon in the trees, and then we get paid for this additional sequestration of carbon in the trees. Again, the situation, we have no future crop tree release, so we have an increase of the carbon stock of this individual tree from time 1 to time 2. When we look at the future crop tree release now under REDD+, this means that we have an additional loss of forest carbon stock when we cut down the competitor trees. And what a tree has to do now is actually to increase the growth by liberation in a way that this additional growth or the additional carbon sequestration by this tree is larger than what we took out of the growing stock by this liberation exercise. And in this situation, we have a positive sum. So here we have actually a benefit from this future crop tree release, and we would get a reimbursement for the CO2 that has been stored in this tree. When you look at this situation here, the growth was actually not that much promoted of this tree. And here at time 2, this additional growth, which was induced by the future crop tree release, does actually not cover the growth that the loss of CO2 that we got from this liberation treatments. And in this case, the liberation treatment, the future crop tree release, would actually result in a negative benefit. Here we would have less carbon than we would have if we would just let the trees grow. So in this situation, we have here a net carbon gain. Here, future crop tree release would be an alternative measure, an alternative sustainable forest management measure under REDD+, because it would gain more carbon in this tree. Here it would not be beneficial because here we would lose carbon. The tree could actually not regrow the volume that the carbon stock that was removed by the future crop tree release. Yeah, but how does reality look like? What you see in this slide is the growth of a non-released tree, and here we took the average on the trees we assessed in our 100 hectare plots, and you can see that over time the trees are accumulating more and more above ground biomass, and that means more and more carbon. When we release a tree, we have actually to subtract the amount of growing stock, of carbon stock that is removed from the forest, and so the tree is growing faster, but it takes a while until the break-even point is reached. That means the point where this loss of carbon by liberation fellings is actually compensated by the additional growth of the tree. And from this break-even point onwards in time, this liberation treatment would be beneficial because the released trees will have now a larger growth and by this a higher carbon accumulation than the non-released tree. But look at the time period that we need. It's somewhere around 140 years. So this liberation investment would actually pay off after a very long period of time. And therefore, it's the question if this is really beneficial. Nobody may know if in 140 years from now, REDD+ is still a viable option to gain benefits from carbon sequestration. There are some take-home messages from our study. First of all, forests can be degraded even if they are still green from the outside. And the reason for this is that you may have low timber volumes, low stem diameters, and a huge abundance of non-commercial trees inside a forest. In not too heavily used forest, there is still a sufficient number of potential crop trees. That means by restricting the harvesting at one point in time is actually a safeguard to have enough trees for harvesting at future occasions. Protecting future crop trees is a silvicultural investment. So when there is logging done, it should be done by reduced impact logging so that the future crop trees are not damaged during harvesting procedures. To release a future crop tree is costly, and it only pays off when the price of wood is high and when the labor costs are low. Otherwise, the return time would be too long. Half of the future crop trees are liberated from competitors in the context of normal use. That is something we found out in our studies, that when you do normal harvesting, then the future crop trees or some of the future crop trees are actually released by the normal harvest. And this might be a sufficient number of liberated future crop trees to gain additional growth. It is worthwhile to protect the future crop trees during harvesting, especially when trees are locked in the neighborhood of the future crop trees. You have to be extremely careful in not damaging the future crop trees. Then we have seen that the number and diameter of future crop trees is a good and simple indicator of stand-specific sustainability, but the number of the future crop trees tells us how much to harvest today, and the diameter of the future crop trees gives an indication of the length of the intervention cycles. We have found in our study that the intervention cycles that you find in logging codes, in harvesting rules in those countries we studied are actually too short, and the recovery time of the forest is much longer than it is anticipated in the logging rules. Yeah, I could give you only a little insight into our study, a very broad overview. Of course, there may be many questions which I would love to answer, but as I am not there, we probably have to use other opportunities to discuss the study. When you are interested in our findings, I would like to point you to a couple of sources. We have developed silvicultural guidelines, which you can find under this link at the FAO. And here you can find a booklet that contains silvicultural guidelines that, for example, give recommendations for the estimation of the intervention cycles and the number of and the volume of harvestable trees. If you are interested in the recovery times and the sustainability, if you are interested in the impacts of future crop tree release under REDD+ as a mitigation activity, or if you are interested in the economic profitability of future crop tree release, you can have a look at these three papers, and they are easy to find on the web. Okay, again, I'm very sorry that I couldn't be with you in person. I hope you could enjoy the presentation and it was not too boring for you. And I hope to see you again in person pretty soon. Bye-bye.
That's the video conference from Professor Cole. Unfortunately, we cannot have a discussion session or question and answer. So please, if you have some interesting question, just open the link that he already shared. You can find some information there about the forest or a logging forest area, how to manage and so on. So that's all the second plenary session today. Thank you very much for your attention. Even is by video. So yeah, the committee tell me Professor Cole maybe he's very tired because he just landed yesterday. Very long journey from Hamburg to here, maybe take some hours. Okay, thank you very much. I give the time to committee. Thank you. Big applause for the presentation, even by video.
Thank you for Professor Michael Cole and also Professor Enos Tangke Arung for the presentation. And ladies and gentlemen, today we are on the coffee break. So if you want to take some coffee, it was in the back of this ballroom. Thank you.
Ya, mulai. Okay. Ladies and gentlemen, let's continue our agenda today. It's the first panel session with Ani Yulistiorini, MSc PhD from State University of Malang and Indah Prihatining Tias, DSSTMT PhD from Mula Warman University. And this session will be moderated by Excuse me. This panel session will be moderated by Dr. Alamsyah.
Assalamualaikum warahmatullahi wabarakatuh. And good morning everyone. Mana suaranya? Good morning everyone. Okay, well, I'd like to explain first what of our invited speakers for today. But before, we'll make an hour to go. For the first invited speaker will be about 30 minutes. And then the second one, Miss Indah, will be also consuming 30 minutes to go. Okay, well, before I give the floor for the first invited speaker, I'd like to read about her curriculum vitae. Ani Yulistiorini, PhD, her Bachelor Environmental Engineering from Institute Technology 10 November, and then her Master from Ghent University, Belgium, and then her PhD from Leeds University, UK, in especially for wastewater treatment. And then research area, water and sanitation and water treatment and design, wastewater treatment, design of wastewater treatment plants, rainwater harvesting and treatment, resource recovery from wastewater. It's about water. And then research experiences. She has 13 research experiences. I think I don't need to read because there is too many. And then her patents, 3. And then publication, about 18 publication. And then work experiences. Deputy Head of Civil Engineering, Malang State University, and then Program Coordinator at Civil Engineering, Malang University, State University, sorry. Well, to use our time effectively, I'll give the floor to the invited speaker, Ani, time is yours.
For housing, residents, property, land, or even industrial development. So that's why the government thing is to find another alternative for capital city allocation. So there are 8 principles of capital city that I took from IKN website, but in this presentation, I only took some point that related to environment. So because in that principle, 100% of wastewater production will be treated by wastewater treatment plant in 2035. And 60% energy efficient will be improved. And from this improvement can be utilized from wastewater as well, because by using anaerobic treatment, we can produce biogas for that can be converted for electricity. More than 75% availability of green open space will be provided for the population, and will be used 100% of sustainable infrastructure concept. For example, eco-friendly construction will be implemented in building that capital city. Okay, so this picture also took from the IKN website. It's a whole picture about IKN area. But in that picture, I consider two environmental point of view. Firstly, about wastewater production. So I don't know in the future how many people will be occupied in that area, but of course that huge area will produce wastewater daily, very huge wastewater volume. So this should be managed and treated properly to prevent environmental destruction in the surrounding of that capital city, because previously that place is tropical forest, is very, we have to reserve that place as a initial function, even though a part of that forest will be built for the new capital city. And then the second one, I'm considered about the stormwater runoff, because that place will be open as a built area, so it will influence the rainwater recharging into the soil. So that's why we have to think how the stormwater runoff should be harvested and managed and also treated, because that can be recharged into the soil, adding for a groundwater table, and also treated for alternative clean water for that community as well. So then why wastewater should be treated? This is because wastewater contain many negative substance, not only bacteria and other microorganisms, but also chemical substance. The study released by the World Bank Water Sanitation Program in 2008 revealed that poor sanitation, including poor hygiene, causes at least 120 million disease episodes and 50,000 premature deaths annually in Indonesia. So that we have to think, treat wastewater properly. Especially in new capital area, we still have a chance to make a good design, and also there are a lot of land availability in there, so we can adjust what kind of wastewater treatment plant suitable for that area. Also, I think concentrated wetland become one of alternative for wastewater in that place, because in Kalimantan they are natural wetland that we can adopt that system to be a wastewater treatment technology. So these two picture shown, the left one is a free water surface, and the right one is subsurface contracted wetland. But mostly for a free surface wetland, we have to consider how to manage the smell and also the mosquito. From the small wastewater treatment wetland that used for decentralized for small community, this is an example that I took from Belgium last month. This in the Lederham, Belgium. This wetland uses for treating mixed wastewater from 14 houses. Use ornamental flower that attract insect and also uh, give a good view of the environment for the community at the surrounding. And it's a sample of extremely large wetland in Oman that are built by a Bauer company for production water, clean water. Also, I can show you this a picture of a converted wetland used in a tourism site in Phi Phi Island in Thailand. So the engineer made this kind of wetland like a butterfly, so it's called butterfly wetland. So it's not only function for wastewater treatment, but also uh, give the people as a like a recreation site. Yeah, for educational, can learn how to treat the wastewater, how to utilize that plant, and so on. Also, this an example for a vertical constructed wetland in that implemented at Kent University campus. This kind of wetland used for treating black water and gray water produced by the student daily from the building, and then treated in this wetland. And the result of the treatment used for toilet flushing. So then by using that treated water, the clean water requirement from the external will be reduced and will be replaced with the treated wastewater. Another example, I implemented this contracted wetland since 2 years ago. This is used to treat just for grey water from camping ground in Selorjo village in Malang. We do regular monitoring on influent and effluent and lab using we have done lab analysis, and the effluent meet the standard quality of wastewater. This has become one example. It's like a natural based technology, which is low cost technology that can be implemented in every location, not only for household, but also for tourism, industry, and also for capital city like IKN. So a concept of wetland for wastewater treatment and for a surface runoff management can be seen in mangrove eco park as well in Tangerang. And this wetland substitute the mangrove. Meanwhile, the area can be used for retention using bioswale to infiltrate runoff water to the soil. And in addition to that, that area also serves for a public facility for recreational place. So in this table, there are some major removal pathway for some parameter like suspended solid, organic matter, nutrient, and pathogen. And for suspended solid, mostly removed through sedimentation and filtration. Organic matter, the same thing, but also through biological degradation in both aerobic and anaerobic removal of dissolved organic matter. Nitrogen and phosphor uptake through plant uptake and then export through biomass. But for nitrogen, also support by ammonification and subsequent nitrification and denitrification process. While in a phosphor, help with absorption and precipitation reaction. In pathogen, it will be removed through sedimentation and filtration as well, and also through natural die-off and predation. So the philosophy of contracted wetland is based on ecosystem services, in which the wetland can give us service to treat the wastewater, reduce organic matter, nutrient, pathogen, and other contaminant, and produce a clean water with less nutrient and pathogen and other contaminant concentration. Also, that wetland will produce oxygen for us, for the environment, and absorb carbon dioxide. In addition to that, this wetland can use for recreational, for let's say for a bird watching and a selfie place and so on. So these are the typical vegetation used in a wetland. So mainly the plant we use should be water-based because it should be adapted to water. There are many type of typical land requirement for making design of wastewater treatment you can find in some sources. But in this case, I focus that contracted wetland, of course, needs a larger area than conventional one, but less requirement for external energy and operational maintenance. These are three types of wetland. Firstly, horizontal flow wetland. This typical wetland usually used for a secondary and tertiary treatment of wastewater, not only domestic but also for non-domestic. And in this typical wetland, the gravel bed is saturated and planted with emergent wetland plants. So enter the treatment system at one end, flows through the gravel media, and is collected on the opposite end of the bed. So for the secondary treatment for domestic wastewater, the gravel depth is generally about 0.5 to 0.7 meter, and the water level is kept 5 to 10 centimeter below the surface. The second type is a vertical flow wetland. This is vertical because the water will be flow vertically through the gravel or gravel bed. And this wetland with intermittent loading are extremely efficient for removal organic carbon in form of PUD or COD, and also very suitable for aerobic process that can be remove significantly of nitrogen through nitrification process. And the third type is a free water surface wetland that commonly used for treating a non-point source such as urban stormwater, agriculture runoff, and also municipal wastewater. And this type of wetland simultaneously will promote both aerobic and anaerobic process. Plant uptake in the free water surface will play as a more significant role in nutrient removal and compared to the other wetland type. And this plant also will release small amount of oxygen, and organic carbon compound into the rooting matrix. And this will fueling both aerobic and anaerobic microbial process. This is an example of my experiment with my student to treat mixed wastewater from student dormitory in State University of Malang campus using vertical and horizontal subsurface flow contracted wetland. This is a design of a horizontal subsurface we use in experiment. We use water spinach, yeah, and then the removal percentage of those parameter is higher than 80%. For the BOD, can reach almost 87%, while TSS ammonium and phosphate higher than 90%. Particularly for ammonium is very good. It has a very good removal because not only occur in nitrification and denitrification, but also uptake by the root plant. And this another picture for vertical subsurface flow contacted wetland. And using vertical subsurface flow wetland will give us more removal percentage than a horizontal one. Although the difference is not too much, but vertical is give us higher than vertical. I mean higher than horizontal, especially for ammonium, almost 100% removed in that method. From this picture, you can see the decreasing of concentration of each contaminant during 1 month. We have experiment. So you can see that vertical subsurface will remove more contaminant than a horizontal one. The same case also occur for the nutrient. So for the filling material, there are many kind of material. For example, for zeolite, good for nitrogen removal, and iron slag or clam cells, good for phosphor removal, and pesticide we can use biochar. Even for expand clay, also good for implement in constructed wetland design. So beside the wastewater, we have to think about surface runoff. So why runoff to be managed environmentally? Yeah, because when we learn from the present situation in Jakarta, the present capital has suffered of flood, land subsidence, and lack of clean water since there is no chance to reclaim water from the rain. And therefore, this one, yeah, there are some picture related with that problem in Jakarta, and therefore the rainwater must be captured and infiltrated instead of only discharging into the river. Yeah, it will be very good if we can infiltrate that rainwater into the soil and will add groundwater table, and also a part of that rainwater can be treated as a clean water alternative. So in terms of runoff treatment, we can use a biofuel as one of the treatment, which is little similar with constructed wetland. And this biofuel provide two primary functions as stormwater conveyance and also for pollutant treatment in urban stormwater runoff. In case of runoff reduction, the swale can effectively convey stormwater runoff from different descent storm when size is appropriately. And this common descent storm is 10-year annual recurrent interval. And if peak flow mitigation or volume reduction is become one objective of swale design, then infiltration of portion of surface runoff would increase design efficiently. Also, we have to think about the plan that we use for that plan in the basefill, and we have to investigate about soil characteristic as well, because infiltration capacity is important in that bioswale. This is an example of typical grass well cross-section and pollutant removal mechanism. So we can also add a check dam to hold more water for further treatment and also infiltration into the soil. This is more detail about biosoil cross-section for pollutant removal mechanism. So by using this biosoil, we not only can infiltrate rainwater or surface runoff into the soil, but also we can treat that stormwater as clean water alternative. So in IKN area, there are still enough area to build a facility that related to water treatment and surface runoff, that so we can manage our environment properly and save the environment and tropical forests. So don't let the problem occur in Jakarta, move to the new capital. So we still have a chance to build a healthier and safer city for the future new capital city. This is, you can see all of my publication in this website. And thank you very much for your attention.
Okay, thank you, Dr. Ani. Keep staying there because we will continue for the second speaker for the time being. And keep staying there, and all the audiences to prepare the questions. Okay, well, I'd like to read the CV of Dr. Indah Prihatining Tias, PhD. Her bachelor, Islamic University of Indonesia, Industrial Engineering, and then her master, Magister Management, Islamic University of Indonesia, and then she has 2 masters, Master of Chemical Engineering, Diponegoro University, and then her PhD in Leuven, Belgium University. Okay, I'd like to explain in terms of the working experiences. Used to be before joining as a lecturer, as the scholar. He has been to the private company, and then after that joined with Mula University since 2008 until now. And then research focus, membrane technology, separation process, and water treatment as well. So both of our speakers today are expert in water, so it is related to our condition and ICANN as well. And list of publication and conference presentation, peer review articles 11, and then non-peer review articles 4, submitted and under review articles 2, and conferences presentation about 7 conferences. She also has big experiences. Okay, well, to use our time effectively, and audiences are waiting for the floor to ask questions. Okay, please, Dr. Indah.
Alam Shah. Good morning, everyone.
Dr. Indah, our teams.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to thank to the organizer of this conference for inviting me to take a part to this event. For me, it's always pleasure to meet colleagues, friends, and also new friends in the conference. Okay, I will share my screen for my presentation. Yes. I hope my slide presentation already on the screen. Okay, As the title of my presentation, the potential of oil palm loose fruits, which as a precursor in the food and in energy industries. Now, as you can see on the slide that I have changed the word precursor with the resources. I think this word is more suitable than precursor. I bring this title today's conference because it is related to the environmental theme, and coincidentally at this time, I and my colleagues, also some students, have been working to explore one of the waste in oil palm plantation called oil palm loose fruits. Oh, I cannot. The background of our research is that, as we know, that Indonesia has around 14,663.6 hectares of oil palm plantation. And addition that palm oil contributes a foreign exchange around 22 until 23 million US dollar per year. And in 2021 was around 30 million US dollar. I think it is the fantastic number of money. If we talk about oil palm, this tree is originated from West Africa, which is an ancient tropical plant that have been known containing a high oil and has a very large potential compared to other vegetables oil. We can compare crops in the term of their yields, how much oil we can produce from 1 hectare of land. This comparison is shown in the chart on the slide. From the chart on the slide, we can see that palm oil achieves a much higher yield than the alternatives. From each hectare of land can produce around 2.9 tons of palm oil. That's around 4 times higher than alternatives such as sunflowers or rapeseed oil, and also 10 to 15 times higher than popular alternative such as coconut and groundnut oil. From the yield comparison as shown in the chart, palm oil achieve a much higher yield. It means that it accounts for every high share of oil production without taking up much land. If we want to limit our environmental impact, reducing the amount of land we devote to agriculture is key to make space for biodiversity. So the less land we need for farming, the better. Because of its high productivity, this plant has been cultivated in Asia and Central America, while the 5 largest palm oil producing countries in the world are Indonesia, Malaysia, Thailand, Colombia, and Nigeria. Small amount of palm oil are grown in many countries, but the global market is dominated by only 2, Indonesia and Malaysia. In 2018, the world produced 70 million tons of oil palm, and Indonesia accounted for 57% of this, is around 40 million tons. And Malaysia produced around 27%, it is around 20 million tons. In the palm oil factory, crude palm oil or CPO or red palm is extracted from the mesocratic part of the palm fruit by mechanic and physics process, then result in the liquid and solid fraction caused by triglycerides. Indonesia has around 39 palm oil processing plants, and CPO is commonly used in the food industry, such as cooking oil, margarine, for fuel source, such as biodiesel, and also other commodities, such as for cosmetics and cleaning product, textiles, also plastic. From the right, we can see the palm oil derivative industrial tree. The main product are oil palm fruit bunches or FFB. However, there are oil palm loose fruits or LF on the ground, which are used to indicate the fresh fruit bunches or FFB are able to be harvested. Besides, LF also found during process of cutting FFB at harvest. It was reported that FFB, because of the bunches are ripe, started when there is 1 until 10 LF or oil palm loose fruits on the ground. In our work, the potential of oil palm loose fruits or LF will be investigated so that could be processes to give added economic value. The sample used in this work were oil palm fresh fruit bunches, FFB, and also oil palm loose fruits, LF, with the various delay in process time, 0, 4, 8, and 12 days. From the picture, we can see from the picture A, we can see the LF or oil palm loose fruits we use in the research, and then we also cook before we extract with the press machine. And for the last picture, there are 3 bottles. There are crude palm oil we get from the oil palm loose fruits. Our research give some results, and from the picture in the left, you can see that from the A, it is a fresh fruit bunches, FFB, and for the picture in B is oil palm loose fruits, and for the picture C, it is oil palm loose fruits, LF, after 12 days. The figure on the left show that fresh fruit bunch is fresher than LF, and white fungus grow on palm loose fruits after 12 days. The picture on the right, on the top, the composition of oil palm loose fruits is 54.25% mesocarp, while the seed is around 45.75%. The picture on the right, on the bottom, shows that extract yields of fresh fruit bunch or FFB and oil palm loose fruits, LF, at the difference in processing delay time. The figure explains that the extract yield decreases with the processing time delay. delay on processing of LF for 12 days results in a significant reduction extract yield. This is due to the delay in the processing time, making the LF dry as the water evaporating. Besides, many fungus present on the LF absorbing water for growing and life. You can see also next. You can see on the slide, the picture on the left. We can see the percentage of free fatty acid and acid value of the fresh fruit bonds, FFB, and oil palm loose fruits, LF, at different processing time delays. The figure shows that free fatty acid and acid value are increasing along with the processing time delay. Chemical content in the mesocarp still can change as the respiration and psychological activities of harvested oil palm fruits still undergo. Moreover, lipase enzyme accelerates the oil hydrolysis process to produce free fatty acid. Unsaturation of an oil could be determined by iodine number. Unsaturation indicates the presence of a double bond. Hence, the lowest iodine value indicates that the oil has a high level of saturation. The picture on the right describes that oil palm loose fruits or LF after 12 days has a high level of oil saturation. For the next slide, we can see on the left that column chart on the left explains that the carotene content increases with increasing processing delay time. The increase in beta carotene content is due to the activity of the lipase enzyme in the mesocarp. While on the graph on the right describe the palmitic acid content of palm oil loose fruits, LF, at different processing time delays. From the graph, we can see that the palmitic acid content increase with increasing processing time delays. And for the research, we can conclude that the oil palm loose fruits have been the potential to have enhanced added value because the mesocarp can be extracted producing crude palm oil or CPO, while the seeds called kernels can be processed to produce oil kernel or palm or kernel oil or PKO. The results on the extraction of oil palm loose fruits or LF contain a high level of carotene and also palmitic acid, so that they have a potential as raw materials for the food and energy industries. However, in the oil palm loose fruits, LF have a challenge with a high free fatty acid, and this free fatty acid can be reduced by physically and chemically. Reduced free fatty acid in oil have been done with the process like adsorption using activated carbon, clay, chitosan, ion exchange resin, IRA 900C, etc. And for the catalyst, for the catalyst, we can use acid catalyst such as sulfuric acid and also TPA. Other process also we can use glycerolysis using some catalyst to speed the reaction. And the last, to reduce fatty acid, also we can use a membrane. And for common membrane used to reduce free fatty acid is ultrafiltration membrane. In our research, we have conducted some experiment to reduce free fatty acid of LF using adsorbent, glycerolysis process, and also acid catalyst. And from adsorbent, we use activated carbon from coconut shell. We use the concentration of activated carbon from 15%, 20%, 25%, and then 30%. And from the graph, we can see that increasing concentration of activated carbon will result in high reducing free fatty acid content. The adsorbent, we use activated carbon from coconut shell, and then was carried out using 100 mass to process to reduce free fatty acid. We were mixing in 300 RPM at temperature 80 degrees Celsius in 1 hour. And for acid catalyst, we use the sulfuric acid with various concentration from 2.5%, 3.5%, 4.5%, and 5.5%. And from the graph, we can see that increasing concentration of sulfuric acid will reduce content of free fatty acid. In this process, we mix in 300 RPM temperature at temperature 60 degrees Celsius for 8 hours. And then the last, we try with the glycerolysis process. Here we use a catalyst zinc chloride with various concentration from 0.15, 0.25, 0.35, and 0.45%. And from the graph, you can see that this process gives a higher reducing of free fatty acid. In this process, we mix with 300 RPM at 175 degrees Celsius temperature for 1 hour. So in our research, we can conclude that the best conditions for the highest free fatty acid conversion or reduction of 99.95% were found by glycerolysis using catalyst zinc chloride. The crude glycerol as a side product of a trans-esterification can be utilized in the glycerolysis to reduce free fatty acid of crude palm oil. So after the problem of high free fatty acid is able to overcome, then the CPO from oil palm loose fruits LF could be for the process to food, energy, or derivative product. Thank you. I think now it's time for question, maybe, Mr.
That one. Thank you.
Okay, thank you, Professor. I think Dr. Adi can reply the answer directly. Please, Doctor.
Thank you for a valuable question. Based on my experience to do experiment and research using a contracted wetland that treat wastewater, even mixed wastewater, black and gray water or gray water itself, up to now is not equal with water company quality, because the treated water that we treated using wastewater is still below the quality of PDM water. Because for example in Malang, the water company use spring water, so no need for treatment, just add with disinfection, and the quality is very good, is class 1, so suitable for drinking water. But the treated water that I produce from wastewater treatment still not meet the standard of drinking water, but equal for clean water, still below drinking water quality, but already meet the effluent standard of wastewater treatment regulation. This is so far I got from my my research. It's not yet equal with drinking water quality. Yeah.
To avoid the possible increase of ammonium or other greenhouse gas emission from the water treatment, whether it the man-made wetlands or the natural wetlands. Thank you very much.
Okay, thank you.
Question. In case of reducing greenhouse gases emission, I think before we use wetland, we have to treat that wastewater using anaerobic treatment, because actually from wastewater treatment itself will produce CO2 and methane gas. But if we capture that gas using anaerobic treatment, and then the biogas that produced from the treatment convert to electricity or gas and used for another thing, it will be reduce the methane gases to the atmosphere. And also in terms of CO2, because for let's say for aerobic treatment, it is always produce CO2. I think the hybrid or the addition of a wetland using that water plant will help to reduce to absorb that CO2 for photosynthesis process. So I will explain that constructed wetland itself is not, I think is not possible to handle everything. So we have to add another treatment. So it means it's hybrid system. So after anaerobic treatment, we capture biogas for electricity and gases, and the effluent from that anaerobic treatment will be policing using constructed wetland, and to produce clean water for irrigation or for gardening or even for recharging into the soil. This is my answer. This is already answer your question.
Is very important, particularly if we talk about the effects of palm oil, and if we can utilize the waste, it's going to be, it's helping how we manage the palm oil itself. And I don't know if it's beyond your sector, but I would like to ask if whether the approach that you do to to manage the waste is applicable at the industrial level, and is there any pilot activities happened in the real field at the moment, or is it is it still in the lab level? Thank you.
Okay, I do hope the question is clear enough, Dr. Indah, okay, that you can reply the answer.
uh, oil palm loose fruits is like such as waste in the palm oil plantation, and we try to utilize this to convert to crude palm oil, but the problem is the high of free fatty acid. For reducing the free fatty acid, still in the lab scale, not yet implement in the industry. But to process oil palm loose fruits, or we call a brondolan sawit, there is maybe one or two industry process this, but yeah, just process, but give like high free fatty acid, so the price is of course low. But if we can increase the quality by reduce the free fatty acid, I hope then the can produce the good quality of CPO from the LF, so the price also will be increased. So for the I will answer that for convert from oil palm loose fruits to be crude palm oil already in the industry, but to reduce free fatty acid still in the lab scale.
Department of Architecture, Mula Warman University. My question for Mrs. Ani Yulistiani. Ma'am, is it different for managing stormwater and wastewater? And then what the best design and control system for preventing flood disaster? Because as we know that our capital city will move from Jakarta to Nusantara, Panajam Regency. So maybe it's my question. Thank you.
warahmatullahi wabarakatuh.
Thank you, Mr. Alam, for your time. And of course, thank you, Ibu Ani Yusilo Rini and Ibu Indah Prihatiningtyas. Ladies and gentlemen, for the second panel session, let's welcome Dr. Andes Wahyu Subhan, MS PhD from Jember University, and Dr. Mekro Permana Pinem from Sultan Ageng Tirtayasa University. The session will be moderated by Rosviansah SP MSI PhD.
Okay, thank you very much the opportunity given to me. Okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon, everybody. And now I will guide the panel session 2 in here, and maybe we just wait because I wait for biodata for invite speakers today. Okay, I'm so sorry. Okay, maybe the can take snacks or other drinks. Maybe the upper side. Okay. Okay, maybe like panel session 1. Firstly, in speaker can present his her research, and after that continue to discussions about material in session 2. Okay, okay. Okay, I will read curriculum vitae for impact speaker today for panel session 2. Firstly, Dr. Andes Wahyu Subuhan, MS PhD, position as Associate Professor of Ecology, Departments of Biology Education, Faculty of Teacher Training and Education, University of Jember, and have an academic career degree, IKIP Malang, for undergraduates and master in Universitas Gadjah Mada, and doctoral program in Slator University. And his positions for position is a lecturer in Faculty of Education and Teacher Training in the University of Jember, Indonesia, and Associate Professor Ecology, Department of Biology Education, University of Jember, Indonesia, 2006 until now. He has many activities in specialist like Himpunan Biologi Indonesia, 2016 until now, the teacher from University of University Gorontalo, it's Ministry of Education, Culture, Research and Higher Education, and many more activity from Impact Speaker today. And okay, and he has many patents, have maybe 3 patents, and many important publications, for 5 years. And okay, next. Okay, maybe this curriculum vitae from Impact Speaker today, and after that, maybe I will chance for Impact Speaker today, and for place and the times I will give to Impact Speaker today. Please, please, okay.
Assalamualaikum warahmatullahi wabarakatuh. I would like to share
Okay. Thank you, Mr. Wahyu.
Okay. My title is presentations. Okay. My title is Secretations and Decisions of decision level of lava clinical monitor on styrofoam plastic use. We know that pollution, especially for plastic.
Okay, I'm so sorry, Mr. Your voice not here from here.
Okay, test.
Okay, thank you
Is
very
it
much.
clear? Sorry. Is it clear?
Your voice is clear.
Okay, thank you so much. Okay, my title is Degradation and Decisions Level of Larva Teniple Monitor on Styrofoam Plastic Waste. we know in our country, pollution is one the big problem, especially for plastic. The plastic production tends to increase year to year, and the consequences of these conditions into the data Hernandez 2021 so that these serious problems. The use of plastic packaging reached 30% globally, and data from INA Plus and Central Statistic Agency informed that plastic waste in Indonesia reached 64 million tons per year. One kind of the plastic is styrofoam. Styrofoam used in numerous usage for human activity, for packaging of food, and another activity on the community for electronic and to isolate the temperature. So the increasing styrofoam use become trust and increase from one year to another year. So it is the problem. Give pollutants to the soil, water, and some people burn the waste to give effect in the air pollution. Some of them to solve the problem using recycle. Yes. So based on the background, it is very urgent to reduce the presence of in the environment by utilizing especially living things. We call biodegradation. Why use sustainable monitor? Because based on the research previously, sustainable monitor have capability to degrade the styrofoam. The capability of the larvae, because the larvae have symbiont in the intestine, especially bacterium, Agrobacterium sp, GT2 strains in the intestine. That's why it is my background to investigate the level degradations and digestion by sustainable monitor larvae on styrofoam waste. Methods, I use experimental laboratory research, and I use 200 larvae, 100 for treatment, 100 for control. Each group have 0.1 to 0.12 grams, and with the length 2 until 3 centimeters. This is a criteria of the larvae, and I use the step for research. First step, preparations, and I use starvations for 3 days for all larvae, and after that I give the styrofoam, and for another groups using concentrate as a normal feeding, and then after that I try to sections the on the crop, intestine, and rectum. I try to give KOH 5% to destroy the organic stuff. So the fragment of the plastic in crop, in intestine, and rectum can be observed in microscope. Okay, this is a result for the research. In the crop, there is a big fragment, and in ventriculus, smaller than in the crop, the fragment of the striform. In the intestine, there is a smaller, and the rectum is a smaller, and the number tend to be increased, but the size is smaller in the rectum. It is indicate that degradations in the digestive tract. So by the number of fragment and the size of the fragment. Okay. This is a result. Styrofoam degradation by the neighbor monitor, 100 individuals. This is initial feed, the average 0.1, and degradations per gram per larvae biomass is 0.017857 gram per day. And for degestions, this is from t-test, so that highly significant between control and treatment. Okay. The table 2 show that there is the number fragment from large size, medium size, and small size. In the crop, this 0.5, and the medium one, and then small 0.3. And it takes 5 to 6 days in the crops, but in the intestine, 7 to 11 days, and the rectum 7 to 12 days. So in the table shows that this is the number fragment as large size, medium size, and small size, and according to the days, increasing the days, increasing the small size in the rectum, intestine, and the rectum. It's so that the average of digestions in a crop of 1.3 and ventriculus 2.5 days, and in the intestine need 1.8 days, and rectum need longer 2.3 days. Okay, so if we calculate larva speech degradation per gram per biomass per number of day to digest from crop to rectum, we got 0.00251 gram per day, or 2.5 milligram per day per individual. Based on the data we can use the technical monitor to reduce the pollutants, especially styrofoam waste. This is the process, how to process digestion in the intestine of technical monitor, how to absorb, first of all, how to discharge from larger size fragment to small size fragment, and then how to work the enzyme produced by bacteria in the intestinum of monitor and convert into biomass, body biomass of the larvae. Okay. The conclusion of the research, the average degradation of styrofoam per gram of larvae biomass is 0.0178 gram per day, and the digestion rate of styrofoam plastic waste by the larvae is 2.5 gram per day per individual. So if the city have how many grams, how many tons, how many kilograms of the waste, just from the findings, we can calculate how many larvae to degrade the waste. Okay. I think that's all my presentations. I give back to moderator. Thank you. Welcome.
That is biodata from the presenters. Okay. And for flash and time, I give to Dr. Pidem. Okay, please, you can present yours. Maybe present your research. Okay, please, Mister.
Okay, thank you for your kind introduction. Could you hear my voice clearly? Hello? Could you hear my voice clearly? Yeah, I think so. Okay, and I already shared my screen, yeah. You can see it as well. Yep. Okay. Good afternoon, everybody. My name is Metro, and I will present some maybe perspective, let's say like that, that what we have today. In this presentation, I will address with the title, The Rise of Indonesia, Problem and our Opportunity, because as we know, all of us, I think, maybe 99.9% we eat rice, maybe a lot. So if we see that the rice is feeding about half of the human population, so the production is really high, and we consume about 740 million tons per year. So it's really huge number. And then if we see Indonesia, we are the third largest just after China and India. So we are actually the third largest rice consumer. But as all of us know that every time we eat rice, it comes from paddy, what we know as paddy, and what we have today, every kilogram that we eat paddy, we left some residue. There is husk. Also, we have rice flour, what I will address today, and also a lot of material left behind, especially for rice flour, because this number is really huge, maybe 2 or 3 times higher than rice itself. It means that if we want to eat 1 kilogram rice, we produce 2 to 3 kilograms of rice flour. Rice flour, what we call zrami in Indonesia. And if you see this data, what will happen if we burn the rice flour? So as you can see here, based on life cycle analysis, rice ranked as the 9th highest of the greenhouse gas emission, because normally farmer didn't treat the rice flour. It is really easy to treat like just open pit burning, what we call it like that. So for the next plantation time, they first clean it up all the rice flour with burning. And here I want to show what will happen in statistical analysis if we burn the rice flour. Then actually this value does not account for the impact of rice flour open pit burning on the GHG. So if you see the 9th rank here, it's based on water consumption, for example, and then fertilizer used to grow the paddy plantation, etc. What they didn't count is the open field burning, because normally outside of Indonesia, they treat it like they make it like as source of biomass energy. There are people also use it as fertilizer, but in Indonesia especially, we don't have any treatment. If we have, maybe not in large number, let's say like that. So normally, if conventional farmer, what they do with the rice straw, they burn it, as simple as that, because it will be easier, much easier, and they didn't see any value benefit if they collected the rice straw. And as we know, what is the effect? If we see the number, it's kilogram of rice straw, approximately 1 to 3 kilogram of waste. It means, and when they make it treat it like open field burning, they produce actually some greenhouse gas, let's say like that, and it's really dangerous. The first thing is dangerous for the local farmer and the environmental area around the paddy plantation itself. And also, when the rice straw is burning, it releases carbon dioxide, methane, and nitrate oxide, carbon monoxide, and all this kind of greenhouse gas. Normally, people didn't see it. Yeah, how much does the gas is released to the air? That if we count in this number, remember we are the third largest rice paddy consumption, and we have a lot rice field in Indonesia. Maybe about one or 10 or 11 million hectares, if I'm not, I remember, yeah, from BPS statistic data, let's say about 11 million hectare paddy plantation in Indonesia. So you can imagine how big this number and how will it affect it, our ozone layer. And I use this here Monte Carlo simulation for see the effect of greenhouse gas contribution here. And I exclude here carbon dioxide because if we do the sensitivity analysis in Monte Carlo simulation, it will be by far greater in carbon dioxide than any other greenhouse gas releases from the rice field burning. So this is the method I use. And here the running simulation, I use this uniform random distribution. So if we see this here by using CO2 equivalent, it means that, for example, methane, if we say like that, and we compare to CO2, methane is 24 times higher than CO2 affected bed effect in the CO2, 25 or about 24 times higher. Yeah. So if you can see here, so nitrous carbon monoxide is and if we calculate and compare it to the how actually how many tons actually that greenhouse gas we release in atmosphere, it's about 310 million tons each year of GHG emission we produce if we didn't treat it the rice straw properly. So it's really a big problem, and we, as all of us know, actually rice straw has good properties. Real point, bio, and then it breed tensile strength, which is good, and we already seen some pattern that they use the rice straw for example, for incorporation with materials building, and then food packaging. That what we already seen today. I think in Germany there is a enterprise, they call it Biolution, and they use it straw not from rice but from um, the source of to make bread. Yeah, so they use it and they make from the straw food packaging. The first one, it use waste, and it means we reduce the waste, and then we reduce open field burning the second time. And the third one, if we use food packaging from bioresources, it means by high biodegradability. Compare with plastic, for example. Plastic maybe can rest in the soil about 200 or 300 years, but if it comes from bioresources, it will be much faster because it naturally biodegrades by itself. And if you see here, there is some application that we see, and I am looking for the data, especially for particle board. Why? Because we all already consume particle board, but particle board that we use mainly come from wood resources. And this is also not good because wood, when we use wood resources, it means that we increase deforestation, which is another kind of harmful to our environment. And what we have today, if we use these ways to a lot of application, food packaging, incorporation materials building, or particle board, it will be really useful and improve our environment. Okay, this is some conclusion that we can draw from this short presentation. The first one is open pit lifestyle burning is really harmful and counterproductive to our future Indonesia's sustainable development, especially if we see SDGs, for example. We can increase our SDGs value by creating this kind of lifestyle to be more sustainable. And it is necessary to create sustainable management of lifestyle in Indonesia, especially to avoid as we can that farmer don't burn their lifestyle. I think we need to make what's a persuasive approach to them. And the third one is particle board is done. It's one of the potential application that can be investigated further, and already some work done in Indonesia also as well. But there is no like commercial product that already released to the market. And if we can change particle board instead of using wood-based product, it means that we also, in the same time, reduce the greenhouse gas emission and also reduce the deforestation in Indonesia. And last one, successful lifestyle management in Indonesia will be generate another source of income for local farmers. So it can also boost their economy. Maybe why they burning, because they can sell it. So there is approach, I think overall approach, like general approach that come from technology point of view, how to make it work, and then also marketing task here, and also policy. I think we need to encourage that Indonesia should treat it and manage this lifestyle better. If not, it will be make our problem. But yeah, like what I say in my title, the first slide, that it could be a problem, but it could be also an opportunity for us. So I think that's all for me. If you have any discussion, maybe you can.
Okay, thank you very much, Dr. Mekro. Okay, okay. After that, next session is discussions. We have two invite speakers today, and for participants, if you have any questions or some questions, you can ask to invite speakers, and okay, you can raise your hands if you have. Okay, please, Miss, please introduce yourself, your name and your institution. Okay, please.
Okay, good afternoon, everybody. My name is Niki Aulia Putri, and I go by Niki. I am from Biology Education Study Program, Faculty of Teacher Training and Education. So I address this question to Mr. Wahyu Subahan. Based on your presentation, sir, there are 200 samples with the laboratory experimental methods, and where 100 as a control and 100 another 100 as a treatment. And at the first day, the second day, and the third day is the starvation mode, and the fourth day is the day where the larva is eat their nutrition. So I would like to ask about the feeding treatment, because I think it has the correlation with their digestive system. And what are the type of nutrition that you use for the 200 sample? Is it the same or is it different between the control and also the treatment? And it is also has the correlation with the level of their ability to degradation and digest the styrofoam. I think it's enough. Thank you.
Okay, thank you very much. Please, Mr. Wahyu, you can answer from participants. Okay, please.
Okay, thank you for the questions, Pak Niki Aulia. That's right. I use 200, 100 for control and 100 for treatment. What the nutritions? For the control, I use concentrate feeding as a normal feeding to culture the Tenipil mortar. And 100 for treatment, I use styrofoam plastic. After 3 days starvations, 1 day after that, I give them the nutrition. For the control, I use in Indonesia pellet concentrate. And now the groups for treatment, I use styrofoam. After 1 day, give the nutrition. All of the some of them be observed how many grams food intakes per day, and then observe in the digestive tract from the proventriculus, for crop, proventriculus, ventriculus, and intestine and rectum. For the day 6, the 6th day, I observe again what happened in the similar observations in the 5 days in the crop, in the intestine, ventriculus, and after that I compare control and the treatment. And so among treatment, what happened in the 5th day and 6th day, 7th day, 8th day, 10th day, and till the 12 days. That's why I can observe how many fragments in the crops compare with in the profen and intestine and the rectum in the same day, and also compare in another day, 50, 60 until 12 days. That's why I can calculate how many fragment and what the size of fragment, and also the speed, the rate of the gradations of the fragment. Okay. Mungkin sorry. Have you got the answer? Sorry.
Okay. Maybe next questions. Okay, we have okay. Maybe okay, please.
Thank you for the opportunity. I would like to ask questions to Pak Mitra. It's very interesting that you study based on the racial way. I would like to ask the first question would be, do you have any data related to how many emissions produced from burning the rice straw? And the second one, I think the solutions to the non-burning of the rice straw to be utilized as particle board is quite fun approach. And I think the reason of the farmers why they tend to burn the straws because it's much cheaper in my opinion. So do you have any simple approach for the farmers so then they're not what is it they wouldn't be choosing burning the rice straws. Thank you.
Okay, thank you for the question. Great question. And I think, yeah, actually I come from engineering point of view, so I calculate it and how the data. But what we need to approach, I think this is about more or less to the social issue. So how we make farmer tend to sell to treat the rice flour, not to burning it. Yeah, we need to provide a factory want to buy it. So for example, instead of burning it, they wasting like that. And if we can, I'm not sure how many rupiahs per kilogram, but if we can make or create a factory that can successfully make a product, that means they have a benefit, and they say instead of burning them, and we can maybe 1,000 or 2,000 per kilo, and it weighs. So they only collect it and they gain money. So I think they will happily to give their waste, and in the same time that they get paid. It's already, I think, in happened in Thailand. There is startup work with this. The problem may be not in the farmer, but I think the problem in us in for example, do we choose instead of using straw, for example, straw plastic, or do we choose resource based bioresources straw or packaging, for example? In terms of consumer, maybe, yeah, we can say that I want to make more sustainable, so I will choose the green one, the bioresources one. But actually, okay, you will get it, but you must pay more, because actually to produce it's much cheaper to produce plastic base than bioresources base. So I think, yeah, that's a complex question. I'm not sure, but maybe government has to release policy to support them, or maybe tax reduction so they can compete in market economy compared to plastic. So the war, I think, let's say the war here is actually between competition between plastic, because the first one, plastic is cheap and the technology already there about 50 years, I think. So really established, really cheap, really fast, and a lot of improvement. But in another one, there is a small company startup like that, and in small capital, and then they should run the business and should to compete with the giant. And I'm not sure. I think last week I read an article how many $1 million maybe plastic food packaging produced in all over the world. It's really huge number. And United Nations already give presentation that if we didn't stop our consumption like this in plastic, in 2050, maybe 30 years from now, it will be more plastic than fish in the ocean. So maybe if we choose cheaper or more expensive, we will be choose cheaper. But if we think longer, and for our children and our grandchildren, I think we should pay more. Yeah, that's my opinion. Yeah, as an engineer. But it's really great question and complex question. I think if any of you have another point of view, it will be welcome. Thank you.
Both presents, we can give applause. Okay. Okay, thank you very much, Dr. Wahyu and Dr. Micro for your time, and maybe we can meet for other time. Okay, thank you very much.
Thank you, Mr. Rofian Shah, SP, MSc PhD, and also thank you to Dr. Wahyu Subhan, MS PhD from Jember University, and Dr. Mekro Permana Pinem from Sultan Ageng Tirtayasa University. And we're going to give the online certificate for both invited speakers. Okay, the first one is for Dr. Wahyu Subhan, MS PhD. And the next one is for Dr. Mekro Permana Pinem. And also we are going to show and give to the first panel session for Ani Yulis Tiorini, MSc PhD from State University of Malang, and Indah Prihatining Tias, DSST MT PhD from Mulawarman University.
Okay, ladies and gentlemen, right now we invite all of you to have a lunch break. The lunch will be served in this ballroom at the backside, and please take notes that we will continue our conference at 13:15 p.m. for the parallel session and the closing ceremony. Thank you.